This is a video lecture on Chapter 3, Matter and Energy for Chem 100. We are going to start by discussing physical and chemical properties. A physical property is defined as a characteristic that can be observed or measured without changing the composition of matter. Very similar to a physical change, which is a change in only appearance of an object. Some very common physical properties include things such as color and density, as well as things like the state of matter that something has. In contrast, a chemical property is a characteristic of a substance that is observed during a chemical reaction in which the chemical composition or identity of the substance is changed. Again, similar to a chemical change, which is overall a change in composition. Two good examples of chemical properties are flammability and reactivity. Let's continue our study with some more definitions. Extensive versus intensive properties. Intensive properties are properties that do not depend on the amount of material. Intensive equals independent. That's how I like to remember it. Extensive properties are the opposite, a property that does depend on the amount of material. So extensive would be mass, and an example of intensive would be density. Using these two definitions, please pause the video and try to identify if the following properties on the right are extensive or intensive. Please check your answers. Volume, energy, heat, and moles are all extensive because they depend on the amount of material present. Something like concentration is similar to density because it is a ratio, so it's intensive. Temperature is an average of all the kinetic energy of molecules, making it intensive. And then things like color and melting point are also intensive. Here we have a couple of slides on some important laws that relate to science. The first law is the law of conservation of matter or mass, and it is defined as the fact that matter cannot be created or destroyed in any chemical process. This explains actually why we will be balancing chemical equations later on in this course. The law of conservation of energy states that energy cannot be created nor destroyed in any process. It can only be transferred or transformed. This is also known as the first law of thermodynamics. And we'll be spending a little bit more time on energy later on in this PowerPoint. Let's review the states of matter. States of matter are physical states of all substances that exist. Physical state is determined by the distance between particles and their relative motion. You'll see here in the diagram that this would represent a solid, this would represent a liquid, and here this would represent a gas. Solids have a definite shape and volume, so they're very fixed. Okay? Liquids have a definite volume, but they don't have a definite shape because they take the shape of their container. And gases are very spread out, so they neither have a definite shape or volume. Let's do some math. We're going to now spend some time talking about density, which is an intensive property of matter. Density is defined as how heavy an object is compared to its size. It is independent of amount. It is a ratio of mass to volume. Its units are grams per ml or grams per cubic centimeter. And the equation is density equals mass over volume. Here, you see that there is something called a density triangle. What you would do if you were going to use this and not have to do algebra is read the question, and you will cover up whatever you are looking for to solve the problem. So if I was looking for density, I would cover up D, and the math that I would do is mass divided by volume. If instead I was looking for mass, I would cover the M, and I would take density times volume. And finally, if I was looking for volume, I would cover the V, and I would take mass over density. It prevents you from needing to do any algebra at all if you just remember the triangle. So let's solve the problem below. What is the density of an object with a mass of 54.2 grams and a volume of 31.7? So I'm looking for density. So I'm going to cover that up in my triangle, and I take my mass divided by volume. And I solve. I want my answer to be to 3 significant figures because this is 3 and this is 3. And then, of course, a number doesn't mean anything without a unit, so I have to put my unit of grams over mLs. Please pause the video at this time and try these practice problems. Please check your answers. The first one, you were finding mass, so you had to multiply D times V. The second one, you were calculating volume, so you had to take mass divided by density. And for the third one, you had to first find the volume. Volume is length times width times height for a cube. Since it is a cube, it's really that number cubed. And then I used that number for my volume, and I took my mass of 32 divided by my 238.3. Okay, let's talk a little bit about mixtures and how to separate mixtures. Mixtures are defined as a combination of different substances in which the components are individually distinct, which means they can be separated by physical processes. There are 2 types, homogeneous and heterogeneous. Homogeneous is a mixture that is uniform, so it looks the same. Okay, it's also called a solution. And heterogeneous is a mixture without a uniform composition, so it's going to look different. Easiest way really to remember these 2 types of mixtures is to look at their prefix. Homo means same, and hetero means different. An example of a homogeneous mixture would be something like juice, or even the air we breathe, right? Because there's lots of different gases in the air, and we can't see them. Heterogeneous examples, things like a jar of coins. Okay, maybe some milk and cereal. And we can see the differences in those, so they're heterogeneous. Let's continue. Here are a few ways that mixtures can be separated. Process of filtration, separating a solid and a liquid using filter paper. We actually completed this in our very first lab. I like to think of this as, old school coffee filters. I know most people nowadays have the Keurigs, but old school coffee filters go through filtration. Distillation is a process that separates mixtures with different boiling points. Okay, it's down here. Basically what happens is if you have a mixture of 2 liquids and one boils at 60 degrees and one boils at 100, The first one will evaporate, and then what happens is after it evaporates here, it goes through a condenser, which is like a cooling tube, and it recondenses into the liquid. A couple of additional key terms on this slide: the word phase, which is a homogeneous state with distinct boundaries and uniform properties, and the word alloy, which is a mixture of two or more solids. For example, brass and steel. Okay. Brass is composed of copper and zinc, and steel is a combination of iron and carbon. These key terms make great multiple choice questions for tests. Let's switch gears here a little bit and talk about different types of energy and some energy math. Energy is the ability to do work. We have a couple of different types of energy: kinetic, which is energy in motion; potential, which is stored energy; and radiant, which is created by the movement of charged particles. For example, sunlight. Most of this is probably a review from some type of science class you took in high school. Now let's talk about specifically heat energy and types of heat energy. We have endothermic reactions and exothermic reactions. In an endothermic reaction, heat is absorbed. Energy is the reactant, which is going to be the first part of a reaction. Okay, so a reactant meaning that it's the beginning of that reaction. It's going to feel cold because heat is being absorbed and being used. And the reactants are going to need energy to proceed to produce products. And you can kind of see here in the example that we added heat. That heat is in the beginning portion of the reaction. Therefore, it's endothermic. And a couple of examples are things like a cold pack or melting ice, right? For ice to melt, it has to absorb heat or absorb energy to go from that solid to liquid state. The way that I remember endothermic is because it kind of sounds like enter. Endo, enter. So heat is entering into the reaction, and therefore it gets cold because it's getting used. The opposite of that is an exothermic reaction. Exo sounds like exit. So heat is leaving the reaction. It's being released, and everything is the opposite. Energy is a product, so it's found at the end of a reaction. Because it's found at the end, it's going to feel hot. The reactants need to get rid of some extra energy, so it gets released. And you can see here in this example that the heat is over here on the product side at the end. And some good examples of exothermic reactions are burning and hot packs or hand warmers. Here we have what are known as energy diagrams of endothermic and exothermic reactions. A couple of things I'd like you to note. Here, for the endothermic, the reactants are low in energy and the products are high. So energy or heat has to be added to get to the top of the hill for the reaction to occur. And for exothermic reactions, your reactants are higher than your products, so there's extra energy that gets released. Basically, these are visual representations of endo and exothermic reactions. We will continue the PowerPoint in our next video.